students, welcome to Vidyavardhini Academy. In this video, we are discussing the calculation of oxidation state and balancing of redox reactions in reactions chapter. Okay, first let us understand what is oxidation state. Oxidation state, it is actually a number, or we can say that it is a charge an atom would possess if all the bonds associated with that atom are broken heterolytically, considering them to be completely ionic. For example, in NH3, there are three nitrogen hydrogen bonds. We have three nitrogen and hydrogen bonds like this with one lone pair. Correct? If we consider all three NH bonds to be ionic, then each H will, that is hydrogen, will possess charge of +1, +1 and +1, where this nitrogen atom will possess -3, because we know this nitrogen atom is more electronegative compared to hydrogen. Right? This is how the balancing of charge will be done in ammonia, and hence the oxidation state, that is nothing but the charge present on nitrogen, is -3. Hope you understood what is exactly oxidation state. Right? Now, why it is important? It is important to know the oxidation state value of an atom in a molecule, so that we will be able to understand the atom is changing from which state to which state, and it is helping us to understand whether the atom is undergoing oxidation or reduction in balancing of redox reactions. Okay. Then how do we calculate? Are we going to write the structure of all the molecules like this and predict what is the charge on the central atom? No. There are some rules. We need to understand, so that will help us to calculate oxidation state. Okay. In that, the first rule is, when any atom is present in its pure state is nothing but uncombined state. If any atom is present in pure state or uncombined state, then OS is oxidation state. Okay, in short I am writing it as OS. Oxidation state of those pure state and uncombined state elements is 0. It is 0. I would like to give some examples here. When I take iron is present in solid state. Alone iron, if it is there, then the oxidation state is 0. Nitrogen will be present as a diatomic molecule, N2 gas. Oxidation state is 0. Okay. Next, coming to second rule. The second rule is, we know that in the periodic table the first group elements are alkali metals, and the oxidation state, or we can say that the valency of alkali metals is +1, and correspondingly their oxidation state is also +1. While alkaline earth metals, that is the second group elements in the periodic table, they have +2 oxidation state. Right? This is the second rule. Next comes the third rule. The third rule is, whenever we have monoatomic ions, for example Na plus, K plus, these are monoatomic ions. Okay. In these cases, the charge is +1, and correspondingly whatever the charge is present on these atoms, that will be their oxidation state. And one more example here, Mg2 plus, Ca2 plus. In this 2 plus is the charge, correspondingly their oxidation state will be +2. And another example, Al3 plus, corresponding their oxidation state will be +3. Okay, this is the third rule. Now let us understand what is the fourth rule. This is very important. That is oxidation state of oxygen. Oxidation state, it is usually -2 in all the cases. Okay. But when it comes to peroxide, that is H2O2, in that case it is -1. In peroxide it is -1. The next rule is with respect to hydrogen. The oxidation state of hydrogen. So we can understand here, when hydrogen combines with the most electropositive element, that is sodium, then the oxidation state of hydrogen will be -1. The same hydrogen, when it combines with the most electronegative element like chlorine, then the oxidation state will be +1. We need to understand whether the hydrogen is connected to most electropositive or most electronegative in order to assign its oxidation state. Okay. And the last final one more rule is, when we consider any molecule, the sum of oxidation state of all the elements will be equal to 0. These are all the rules we must keep in mind while calculating oxidation state of an atom in a molecule. Okay, now we will see some of the examples. In this example, we need to calculate the oxidation state of the underlined element, that is manganese, and the compound given is K-4. We'll be explaining now the procedure, what all things to be followed to calculate oxidation state. Okay, let the oxidation state of manganese be X. Consider it as X. Okay, now we have potassium. Potassium belongs to here alkali metal. Oxidation state is +1. Okay, I will take this as +1. Plus K-4, I will take it as X. Plus there are 4 oxygen atoms. 4 into oxygen atom oxidation state is -2. Hence write -2 equals to 0. X -7. 4 into -2 -8 plus 1 plus -7, that is equal to 0. X equals to +7. Hence the oxidation state of manganese is +7. Okay, now we will see one more example, and the example is NO3 minus. In this, the oxidation state that we are supposed to calculate is for nitrogen. I will be taking this as X. Let the oxidation state of nitrogen be X. Okay. So here X plus, there are 3 oxygen atoms, 3 into -2, that is equal to, this is not a neutral molecule, there is a negative charge on this, this is an anion, hence that is equal to -1. If it is -2 we have to take. Whatever the charge present on the molecule, the same charge we have to equate it for. Okay. X equals to -1, 3 into -2, -6. -6, if it comes this side, it is +6. Hence, X equals to -1 plus 6, it is +5. Oxidation state of nitrogen in NO3 minus is +5. Another example here it is. Another example, that is NO2 plus. Here also I will be taking the oxidation state NO2 plus, in which we need to calculate oxidation state for nitrogen. Now, let the oxidation state of nitrogen be. Let the oxidation state of nitrogen be. Nitrogen be X. Okay. X plus, there are 2 oxygen atoms, 2 into -2, that is equal to +1. Why +1? Because the overall charge on the molecule is +1. X, 2 into -2, it is -4. X minus 4 equals to +1. X equals to +1 plus 4, it is +5. Hence the oxidation state of nitrogen in NO2 plus is +5. This is how we calculate oxidation state of an atom in a given molecule. Okay, now I am giving you few questions here. Try to calculate oxidation state of these compounds, and here I am underlining the element to which you have to calculate the oxidation state. And these questions what I am giving, you can calculate and write down answer in the comment box. Okay, first one, K2Cr2O7, in which the underlined element is chromium. And the second question is calculating oxidation state of iron in Fe2O3, underlined is iron. Okay, hope you understood the rules that should be followed to calculate oxidation state of an atom in a molecule. Okay, in the next videos we will be understanding how to balance redox reactions in detail. Okay, in order to learn chemistry in a easy way, please do subscribe to our channel Vidyavardhini Academy. Thank you.